Okay, in this video we're going to explore a little bit more deeply the nature of neutral objects. And neutral objects is not something you would learn in middle school or in elementary school usually, because it's kind of complicated to think about why neutral objects have this weird behavior, and that is that neutral objects are always attracted to any charged object. And it doesn't matter whether the object is positively charged or negatively charged, that neutral object is always going to be attracted to charged objects. And it's not obvious why would that be the case. You know, for example, if you rub a balloon against a sweater, it will stick to the wall even though you know the wall is not charged, right? So you have a charged balloon, you have a neutral wall, and somehow the two are able to stick to each other. There's somehow a force in between those two. And so in order to understand that, let's start with the pith ball. We're going to start with a neutral pith ball, of course, as we're focused on neutral objects. So in a neutral pith ball, you would see that the charges were evenly distributed. So the positives were evenly distributed throughout the object, the negatives were evenly distributed. They wouldn't be all clustered together because, of course, negative charges don't like each other and positive charges don't like each other. So they always try to spread out as much as they possibly can. And let's take a look at two different situations. So let's say, for example, that we bring a charged object like a negatively charged plastic rod. So I'm going to put a bunch of negative charges on this guy. All right, so there's a plastic rod that's completely covered with negative charges. The pith ball, we're going to put the pith ball over here nearby. And what's going to happen when you bring the pith ball nearby to the charged rod is that things are going to start to happen inside the pith ball. This was in the video called Polarization. The polarization is going to occur, and that's going to cause the positive charges to be drawn a little bit closer to the negative charges, and then the negative charges that were here are going to get pushed away, and so the thing will be polarized, okay? And that is very much part of the explanation about why neutral objects are always attracted to charged objects. The lowest level of understanding is just knowing that that's true. Understanding that it has something to do with polarization moves you up another level. But the best answer is looking at the difference in the distance between the like charges and the opposite charges. So let's say, for example, we look at the opposite charges, which are right here. They have a certain distance away. Okay, and that distance is pretty small. And of course, like charges are always attracted to opposite charge, or I should say positive charges are always attracted to negative charges, so this is attraction. Now, what about for these guys? Now, notice that the negative charges are a little further away, of course, because they were pushed away by the rod. So these like charges, both negative, are a little bit further away. Okay, and so there's their distance. Okay, now they, of course, are not an attractive force. They are a repulsive force. Now, one thing really important to understand about the electrostatic force, or the force between electric charges, is that it does depend on the distance. So the farther away two charges are from each other, the weaker the force will be. So because these like charges are further away and they're producing a repulsive force, then the opposite charges, which are closer and are causing an attractive force, we will always find that the attraction is always greater than the repulsion, because these positive charges will always be closer than the like charges are here. But let's say, for example, you might think, well, what if this was a positively charged rod? Would that have changed anything? There is some change in terms of the way the charges are going to look, but there is no difference in the fact that we will get attraction. So here is our positively charged plastic rod, or let's say it's a glass rod, for example, and we have the pith ball here. Okay, so what's different with this one is that the negatives are going to be drawn towards the positives. So the negatives will be on the left side, and the positives will be pushed away, and they'll be over on the right side. But now if you look again, this force between the positives in the plastic rod and the negatives in the pith ball, that is an attractive force. If you look at the positives who've been pushed over here to the side, they're much further away, and that is a repulsive force. So it's not that there is only attraction with neutral objects. The neutral object is going to have both kinds of charges. So it's going to experience both attraction and repulsion. But because of the way the charges move to polarize themselves, the way the pith ball becomes polarized, it always means that the opposite charges will be a little closer, and therefore the attractive force will be a little bit stronger than the repulsive force. And as this pith ball gets closer to the charged rod, you would see that force, that difference in force, becomes even stronger. longer. So when these two guys are nearly next to each other, the negative charges will still be a little bit of a distance away. And so it'll be a significant difference in the attractive force compared to the repulsive force, and therefore you always end up with attraction. Now, let's take a look at some example problems of how this idea of the neutral objects always being attracted to charged objects, it kind of creates a little bit of a problem when you're trying to figure out what charges objects have. So we're going to look at 3 different situations. Each one will get successively more and more complex, more challenging, more difficult to figure out. And so one of the things that we're going to want to do is, if it's possible that there's more than one type of charge, then we want to identify that that is a possibility. So we're going to go through and we're going to test out 3 objects, object A, object B, and object C. Now, they may be charged or maybe they're not charged. Right? We won't know right now ahead of time, but what we will take is each of the objects. So I will test A against B, and I will test A against C. And then the only other test to do is to test B against C. So I will do all 3 different possible tests that we can do to see the effects of the forces on these 3 charged objects. And then from that, we should be able to work out, okay, who is positive, who is negative, and were there any of these charges that could have been neutral. So in the first example, we're going to have A is attracted to B, B repels C, and then A attracts C. Now you want to write this down. If you notice, I left quite a large space between here. And the reason is because I'm going to put symbols above the letters to represent what are their possible charges. This is just a way of me organizing my thoughts so that I can come up with the best possible answer for these. Now, one of the charges has to be given to you. If you don't know anything about any of these charges, then we can't really know anything about what the charges are. But in this case, we are told that A is a positive charge. Okay, so that means that B could either be negative, that's one possibility. A negative would attract to a positive, but as we just said, so would a neutral. So right now, the fact that B attracted to A does not guarantee that B is even charged. It could be the opposite charge or it could be neutral. Now I'm going to skip this because I don't know the charge on C right now, but I do know the charge on A is still positive. So let's take a look at what could happen with C. Well, it says that C then could be negative because that's one possibility that would produce attraction. Or it could also be neutral. Okay, so I have essentially 4 different possibilities about what B and C could be. They could both be negative, they could both be neutral, or one could be negative and one is neutral, or they could be reversed. This guy is neutral and this guy is negative. So now we need this middle test. The middle test should help us to reveal something about what it is. Now clearly it's not both neutral, because if they were both neutral, there would be no reaction. And actually, it cannot be one negative and one neutral because that should have caused attraction. If C were negative and B were neutral, then that would have caused attraction. But that's not what happened. What we saw was repulsion, and that can only occur if B is negative and C is negative. That is the only way that I would get repulsion in this middle test. So in this first example, we are able to definitively tell you this is the charges. There's no question about it. They are definitely both negatively charged objects. So let's take a look at a little bit more challenging problem. So in this one, A still is attracted to B, but this time B attracts to C, and it's A and C. These are the 2 who are going to repel each other. So just like we did before, I'm going to write the possible charges directly above the letters. That's why I left the little gaps here so that I could keep the letters separated from each other. So if A is negative, okay, then let's start going through and working out some of the other charges. Well, the best thing to look at would be definitely to look at this test because this produced repulsion. That means that C is negative. Okay, so when it comes to C, I am done. There is no question. C must be a negative charge because that is the only way you could end up with repulsion between A and C. So now the question is, what is B? Can we determine definitively what is the possible charges on B? We now know that C is negative. I'm going to go ahead and add that in there. All right, well, for B, obviously one possibility is that it's positive, but we can't rule out the possibility that it is neutral because neutral objects would also attract to a negative object. If we look at the second test, we see basically the exact same thing. It could be positive or it could be neutral. It's really no way to know from this. So that leaves me with a little bit of a dilemma. I know that B is positive or it's neutral. But at this point right now, I do not know which one B is. I would need to bring in some new object to test B against. And what I would want to bring in is a positive object. So when I bring in a positive object, what I should see, if B really is positive, what I should see is repulsion. And if I bring in a positive object and I find that there is attraction, that means that B must be neutral, because then B would have attracted to both the negative object and also to a positive object. And that can only happen if the object is neutral. Okay, in our last situation, you're going to find that it is even more difficult to figure out what the charge on the two are, but we will be able to narrow it down to a couple of possibilities. What makes this problem especially difficult is that it's all attraction. Everybody is attracted to everybody else. So then that's going to leave a little bit of a problem in terms of working out what are definitively the charges. But one thing that we do know is that A is positive. Right, so A, you were informed that A is a positive charge. So what's the possibilities for B? Well, B could be negative or it could be neutral, as we've established. And then over here, the same thing for C. So C could be negative or it could be neutral, because both of those will cause attraction. So now we are left with 4 possibilities for the combinations of B and C. So let's knock a few of them out right away. First of all, they're not both negative. Okay, if they had both been negative, we would have seen repulsion here. So they're definitely not both negative. I can also say that they're not both neutral either, because if they were both neutral, neutral objects are not affected by other neutral objects. This is why the secret life of charges is so hidden from you, because most of the time, everything that you look at, these are neutral objects, and neutral objects are not affected by other neutral objects. There's no attractive or repulsive force between those two. So that leaves only 2 other possibilities. One is that B is the negative one and C is neutral, and that would create this result for this test. But if I reverse them and I make B neutral and I make C negative, well, then I would end up with the same results. I would find that B and C would attract each other, and with no other information, which I don't have any other information, I could not tell you which one of the 2 it is. But I can tell you it's one of 2 possibilities. So either B is negative and C is neutral, that's one possibility, or B is neutral and C is the negative one. So it's either this or it's this. Those are the only 2 possibilities, but I couldn't tell you which one it is. So at this point right now, I could not tell you whether B is charged or whether C is charged, but one thing I can tell you is that at least one of them is charged with a negative charge, and the other one must be neutral, because that is the only way you could get all 3 of these tests to work the way that they do. So neutral objects they're a little tricky. You really got to think things through very carefully, and clearly it should be pretty obvious to everyone that attraction is not a great test, because attraction only narrows it down to 2 possibilities. It's repulsion. Repulsion is the good test. That's the better test, because when you see repulsion, you know for sure that those objects have the same charge. And so it makes it more clear as to whether there is a charged object or not a charged object, whereas attraction leaves a little bit of ambiguity as far as which is the charged object and which one is not.